Good morning, ladies and gentlemen. I thank all of you for supporting my channel and subscribing and sharing it to your friends. Today, we will talk about an instrument which is installed in the aircraft, which we call it as a ADF, that is Automatic Direction Finder. ADF. Automatic Direction Finder is an instrument which is there inside the aircraft which finds the direction of a ground station which is transmitting a signal. So the name of the ground station, it is called as a Non-Directional Beacon, NDB. The non-directional beacon transmits wave in all the direction within a frequency of 190 kilohertz to 1750 kilohertz. This is in the LF and the MF band. The aircraft instrument, the ADF, will be able to find out the direction in which this beacon is located, and if it is an instrument like this, and let us assume that this is the direction in which the NDB is there, the aircraft, the needle inside the aircraft will show like this. This is the direction in which the NDB or the ground station is there. So now let's have a look at how this ADF works. The principle of operation of ADF is bearing by loop theory. So what exactly is bearing by the loop theory? Okay, now let us assume that the NDB is here and it is transmitting a vertically polarized wave in all the direction like this. So there will be antenna inside the aircraft which looks like the loop like this, okay, with the vertical members wound around this loop. This is the vertical member of the antenna. This is the vertical member of the antenna, and this is the horizontal member, and this is the horizontal member. As you see very clearly here, the NDB is transmitting a vertically polarized wave. So therefore, the vertical members of this loop antenna will be able to pick up these waves which are being transmitted from the NDB. Let us place the loop antenna here like this, and this arm is a red arm, so I will write a red arm, and this is the black arm. Black arm is here, and let me draw this loop antenna like this here. So since it is a vertically polarized wave, the vertical member of this particular antenna will receive the signal. Okay, so now if you have a look, this black arm is receiving the signal at this moment of time, whereas the red arm is receiving the signal at this moment of time. If you see, it is seen clearly that the phase of the wave which are striking the arms of these antenna are different. Because of the phase difference, there will be an EMF generated in this particular loop, and the current will start flowing. Let us say that current is started flowing from here. So now like this, the current is flowing in this direction. Yes. Okay, now let me turn this antenna by 90 degrees. That is, I will place into the direction which is 90 degrees to the direction from where the waves are coming. Since it is 90 degrees from where the waves are coming, all the waves which are coming will strike both the vertical members of this antenna at the same time. Therefore, the distance traveled by this wave will be the same, and there will be no phase differences because they are striking at the same arm at the same time. So when I turn this antenna by 90 degrees, there will be no zero EMF will be produced. Let me further turn this loop antenna by a complete 180 degrees. So now the red arm has come up to this place, and the black arm has gone to this direction. The red arm is here, the black arm is here. Now, similarly, the current will be induced. Am I right? So here, the current earlier was induced by this red arm. Now, the current is induced by the black arm now. So what is happening is the polarity or the direction in which the wave is, the EMF is being created will be different, right? So at this point of time, when I turn by 180 degrees, the polarity of the electric current which is generated is reversed. Now I turn the antenna by 270 degrees, now it has become perpendicular to the direction in which the wave is coming. So there will be no phase difference because the distance traveled by the wave is the same. So the current induced will be 0 once again. When I turn by 360 degree, it is like the original place where the EMF will be produced once again in the original direction. So the current or the EMF which is produced by this antenna when the wave from an NDB hit will be a function of the direction from which the waves are coming. So now with this information, I can find out the direction of the beacon. Okay, now let us assume that all of you are the beacon and this is the antenna. Yes? So what is going to happen is when this antenna is like this, no current, maximum current in one direction, no current, maximum current once again. So now measuring a current, and if we talk about the current, okay, this is an alternating current, AC current. The AC current is also like this in a form of sine curve. Measuring the current here and the finding out the difference, like let's just say when the antenna is like this, maximum current, it is going to be here. So it is very difficult for the instrument to measure a little bit of change in the current because of the little bit of change in the direction from where the wave is coming. Now if I turn this like this, so at one particular point of time, that is at when the antenna is perpendicular to the wave, there will be zero current. It is easy to measure the zero current. So therefore the ADF will find the direction when the antennas are at perpendicular to the direction on which the wave is coming. So I will hunt for the 0 point. So therefore the 0 point is also what we call it as a null, N-U-L-L, null point. So no current, null point. So if you are in front of me like this, okay, if you are an antenna and if you are a transmitter, it is an antenna, there will be no current at this moment of time. Similarly, if I am the transmitter and this is the antenna, okay, when the wave is transmitting like this, okay, the current will also be 0, right? So therefore, I do not know, this antenna cannot distinguish that whether the NDB is that side of this antenna or this side of this antenna. This is what we call it as a 180 degree ambiguity. So the antenna will not be able to decipher whether the NDB is that side or this side. So there is always a 180 degree ambiguity. So now let me draw a polar diagram of this loop antenna. That is how the current. So now as we see that when the antenna is perpendicular to the direction on which the wave is coming, there will be no current generated. As the antenna rotates about the axis, okay, there will be an increase in the current. There will be an increase in the current, and the current will drop to 0 when it is turned by 180 degrees, and thereafter there will be negative current. Okay, that is the reverse polarity current will be formed. Okay, with increasing EMF. So let's say that this is the positive and this is the negative. So if we plot a polar diagram, the polar diagram of the current which is going to be induced from this loop antenna will look like this. Okay, when it is like this, okay, no current. When I turn, it will increase in the positive way, touch the maximum value, thereafter it will reduce to 0 once again. And if it comes onto this position 1 again, it is gonna increase in the negative value and now come to 0 once again. So this is the polar diagram of a loop antenna which looks like a figure of 8. So my NDB can lie in this, as we have just discussed, in this direction also, in this direction also. So now there is a 180-degree ambiguity because the antenna is not able to decide whether the NDB is this side of or whether this side. Okay, now how do we solve it? We introduce an aerial. We introduce an aerial which is in between this. This is aerial is what we call it as a sense aerial. Sense aerial. Since it is a single vertical member, okay, which is a sense aerial, irrespective of the turn, irrespective of whether the antenna is turning or not, the distance from the beacon will not change. So therefore, the polar diagram, if we draw the polar diagram of this sense aerial, irrespective of the direction in which the antenna is lined up, the current induced is going to be the same current will be induced. So the polar diagram will look like a circle. So now I have the polar diagram from the sense aerial and the polar diagram from the loop aerial. So now both of them will be combined now together by the aircraft equipment, and once it is combined, what is going to happen is like it will form a shape like this. Doesn't it look like a heart? So this final polar diagram, what we are drawing after the combination of this sense aerial and the loop aerial is what we call it as a cardioid. Now, what happens is, if I keep moving this antenna, okay, whenever you are there, let's assume that you are an NDB, whenever you are this side of the antenna, the current induced will be 0. When it is turned like this, the current induced is not 0. So now from two null positions, I have resolved it to the one null only, because of which I come to know that the transmitter is that side and the not this side. That is how the ADF finds out the direction of the beacon using the loop and the sense antenna. So you have understood the basic principle of working of the ADF. Continue watching my series on the ADF. In my next class, I will talk about how it is going to be integrated inside the aircraft, and in the next class, I'm going to be talking about the errors of the ADF and how to minimize those errors in the ADF. Thank you, ladies and gentlemen, for watching my channel. Kindly do like, subscribe, and share it to your friends. Good night.